Welcome to the video for C2.2.10 where we're going to look at atomic structure in the periodic table. So our learning objectives for today are to explain the arrangement of the periodic table. So in the last lesson we looked at the development of the periodic table. So today's lesson is about the modern periodic table and how it's arranged. So you need to copy this text into your exercise book. So the elements in the modern periodic table are arranged in order of their atomic number. So if you think back to the last lesson, we learned that to start with, it was in terms of their mass. So now it's arranged in order of the atomic number, and the atomic number is the same as the number of protons that an element's got, because each element has got a different number of protons. So the number of protons defines which element it is. Okay. Now, because in a neutral atom, the number of protons is the same as the number of electrons, then it's also arranged in the same as the number of electrons an element's got. So this means that the periodic table is arranged in terms of the electronic structure and their properties. Okay, so elements in the same vertical group are going to have the same number of outer shell electrons. So this diagram's a little bit confusing. So the groups are the columns here. So let me get my pen on. So the groups are the columns, and these are the group numbers here. So they're the group numbers. And in previous lessons, we learned that if it's in group 1, it's got 1 electron in the outer shell. If it's in group 2, it's got 2 electrons in the outer shell. If it's in group 3, it's got 3 electrons, 4 electrons in 4, 5 electrons in 5, 6 electrons in 6, 7 electrons in there. And then in this last one, which is sometimes called group 0 and sometimes group 8, it's going to have 8, apart from helium, which has 2. Okay, so the group number is the same as the number of number of electrons there are in the outer shell. So the period is the rows going across. Now, sometimes people miss the first period. So period 1 is hydrogen and helium, and then lithium, beryllium, etc. is period 2. Sodium, magnesium is 3, etc. So we go 4, 5, 6, 7. So if we look at them, we've already said that elements in the same group have got the same number of outer shell electrons, and that's the same as their group number. Elements in the same period are going to have the same number of electron shells. So hydrogen and helium here, they're in period 1, so they've got 1 shell. Lithium, beryllium, etc. are in period 2, so they've got 2 shells of electrons. Sodium, magnesium are in period 3, so they've got 3 shells of electrons. And remember, we looked back in the first lesson of this unit, this red staircase here showed that the division between the metals and the non-metals. So anything to the left of this is a metal, anything to the right, so this bit here are non-metals, and anything to the left is a metal, except for hydrogen, which is a non-metal. So sometimes hydrogen's put here, kind of floating in the middle, and sometimes it's put here. But regardless of where it's put, it's a non-metal. Okay, so that's all the information that you need to know. Hopefully you got that copied down. So the only task you need to do from this, apart from copying the text on the previous slide, is to just find these elements in the periodic table and just write down which group and period they're in, so that we get used to identifying which group and period elements are in. Okay, so if you pause the video, copy that table down, complete it, the answers will be on the next slide. Okay, so hopefully we agree with all of these. If you don't, let me know if you're not sure about any of them. Okay, thank you for listening. See you next time.